The next presenter is going to be Jaakko Rautanen from Rautanen-yhtiöt, and he'll be talking about streaming telemetry with something I don't think we've tried before, a live demonstration that will actually work, right? Take it away.
Thank you. So, I'm always keen to see and understand. And that's why I'm giving a presentation, actually live demo, about streaming telemetry to you. Because streaming telemetry is something which certainly helps you to see and understand. So with that said, let's jump right into the demo. Here we can see pretty basic traffic rate figures. And as there is not that much traffic going on, let's try to initiate some. So I will jump into the console and start initiating traffic. And here in the dashboard we now start to see traffic figures raising. So it seems that they are kind of ramping up and eventually reaching a steady state. And if we deep dive into this a little bit, I will stop the traffic. Sorry. So that we will get a nice figure here. And eventually the traffic stopped. And let's take that moment here. So now we are seeing that kind of a nice traffic figure. But whenever I'm seeing something like this, I'm thinking that this is not true. Because, you know, if you take Ethernet interface, it's always full line rate. So if you go to the very narrow time frame, traffic is always sent as a full line rate. So this has to be some kind of average, which it is. So to demonstrate the capabilities of streaming telemetry, let's take a look to the way more granular data. So here we have a same data, actually, same data, but different representation. So the upper graphs are from the devices themselves. They are reporting the traffic rate at any given point in time. But the lower graphs are about the same interfaces, but they are cumulative octet counters from the interfaces. And we are subscribing them with 1 second intervals. So there we can see that the traffic actually was way more bursty than it seems to be. So let's do some fun things here. Oh, I need to sign in. No, it's about the... Let's do like that. And let's refresh once in a second. So now we have traffic running again, or the dashboard view is running again. So let's go back to the network devices actually. I will SSH to one of the switches. And I will take a look to the IP address of an interface, and then I will ping in network instance default interval 2 seconds, as we have the 1 second granularity. Let's say size is 500 bytes and the count is going to be 3. And then we will ping the neighbor router here, so I just know that it's 1 plus for the interface IP. Now pings are running. Let's get back to the graphs. So here we saw like 3 spikes. They're actually the 3 pings. So this is kind of the granularity you can go with the streaming telemetry. We can actually prove that even better to, let's just make 1000 bytes and count 1. Here we go. We can see the single ping. Now, I'm not saying you should go with 1 second intervals for all of your interfaces all the time or all of your data, but I'm just trying to prove the point that this is the granularity you can go. Maybe you can implement a solution to do this on demand and do not less granular other times. So here in interface dashboard we have other things as well, such as administrative and operative status of the interfaces, and those are actually string values in this case. They are not numeric values, so you can do things like that. I did, with this type of dashboard, I did for one customer the network device software versions. So you can see how the upgrades are going or how they went last night in the timeline. Now let's take a look to some other dashboards. So what else data we could have? Here we have a BGP related numeric information. So total number of peers in established states, and then number of peers in non-established states, so basically down. And we can actually see that leaf 3 and spine 2 has 1 peer down. So let's see if we can come back to later that and see why that is down. Then you can do fancy things like this. So this is actually a draw.io diagram, and then it's converted to the SVG file, and the telemetry is reflected on top of the SVG. So let's try to initiate traffic now and see how it reflects here. Now, as you can see, the traffic rates are reflecting to the diagram. So actually, client 2 is sending traffic. It's distributed, it's load balanced by leaf 2. Obviously, we can see it here. And it's going to the spine 1 and 2, forwarded to the leaf 1, and then forwarded to the client 1. And here we can as well see that the leaf 3 has an interface down, so maybe that was the reason for BGP peer down. Let's try to fix that. Let's SSH to the leaf 3, and I actually know it is down, it's admin down, so I will brought it up. And here we go. The interface came up. So these are just some examples of what you can do. Now we can take a look back to the BGP information, if we can get that corrected. You can do all sorts of things with the telemetry data and all sorts of dashboards. So these are just some small examples. I think here we go. So it just took a while for BGP to come up. Now we don't have any BGP peers down. So couple of slides in the end. So I have seen other things in telemetry and found them really useful. When I first discovered the telemetry, I thought that's just a better way of collecting graph information, interface statistics as we saw. But which it is, but it's much more. So one of the very useful uses for telemetry is table type of data. So what if you can see routing table, ARP table, MAC table, LLDP table, multicast routing table, whatever table in any given point in time. If you can go back in time and see how it was like 2 days ago at 4 a.m. or 1, when you are troubleshooting afterwards, that's really useful. That's possible with streaming telemetry. Unfortunately, I wasn't able to have it here in this demo. I have the data, it's just about the visualization part. So the next step from that is the comparing the same table between the 2 timestamps. And this is really useful. I have used that a lot in network changes. So say, for example, you are doing some change in a network and you expect that the routing table, for example, before and after the change are equal. So what if you can check after the change and compare that routing table like 1 hour ago or 30 minutes ago and see only the difference, only added and removed lines, and then you can confirm whether your expectations were correct or not. So the telemetry in this lab was based on GNMI. GNMI is Google Network Management Interface. It uses gRPC as a protocol, which is Google Remote Procedure Call. It's widely implemented in the various network device vendors' products. It's highly efficient. It's a binary protocol as compared to its kind of competitor, which is way more old protocol, the netconf, which is using like XML, which is very verbose protocol, and then that's coded in the ASCII characters and so on. So the volume of the streams are actually quite low. It's not only for telemetry, it's also for configuration of the network devices, and it uses Yang-based data models. So if this presentation was interesting for somebody, the way I did the demo is as interesting for me at least. So everything in this lab was containers. So if we go from the right to the left, so we had 3 clients. They are just Linux clients. Then we had 5 switches. They were actually running Nokia SR Linux. Why Nokia? Just because they provide their image for free, and I mean without any registration. You can just pull it. So make it really easy to share this lab, and I'm gonna share this with you, so you can play with it. Then we have this green management network, which is connecting these all nodes together, and there are this telemetry stack. GNMI-C, which is GNMI client, open source client. It's subscribing the data from the network devices, pushing that to the InfluxDB database, and then Grafana is used to visualize it from the InfluxDB. And all this wiring of these containers are done by Container Lab, which is really good open source product as well. And because of that, I can run that in GitHub Codespaces, which is a cloud service. And given that you all have a GitHub account, you can run 120 CPU hours a month for free. And I actually counted the clicks. This is my repo. Just go to that, click the Run in Codespaces button, and in 4 clicks, 1 command, you have the exact same environment running, no matter what color your laptop has. So I think I was able to give this presentation without mentioning the very specific old protocol, which is not simple, never was used widely for network management, but yes, it was a protocol. With that said, keep streaming and stop polling. Thank you.
Are there any questions? You're going to be here all evening as well, right?
Not exactly.
Dinner?
No.
No, not even dinner?
No.
Okay, so you need to really ask your questions now then.
Or then you can reach me later.
Anyway, there will be another presentation in the program in a few minutes that will talk about something that you can do in the future within this same topic. So stay tuned.